We started this module by stating that the periodic table is perhaps the best known icon in chemistry. But how did it get to be the way it is? Its history goes back to the 1800s, before subatomic particles were even known. Dalton and others made lists of elements and their masses, but it wasn't until the 1860s when Mendeleev tried to arrange the elements in a way to show more than just their masses. Mendeleev, a Russian chemist, tried to show the elements arranged not just by mass, but also grouped by their properties, specifically their chemical properties. Let's see how this might work by considering some elements and the compounds they make when they react with chlorine. Now, the lightest known element that does not react with chlorine is helium. We show the molar mass in parentheses. The next heaviest element is lithium, whose molar mass is 7. It forms a compound with chlorine that has 1 chlorine for each lithium. We write the chemical formula LiCl. The next heaviest element is beryllium, which makes a compound that has 2 chlorines for each beryllium, BeCl2. As we look at more elements in order of mass, they seem to take on more chlorine atoms, until eventually we arrive at neon, which is another element that does not react with chlorine. After that in mass is sodium, which makes a 1-to-1 compound. Next is magnesium, which is 1-to-2. The pattern is repeating itself. But then it gets interesting. The next heaviest element that does not react with chlorine is argon, which weighs 40. But then there is potassium, which is lighter at 39, but makes a 1-to-1 compound with chlorine. The predicament is whether to place potassium before argon, as the mass would suggest, or after argon, as the chemical properties would suggest. Mendeleev's table would place it after argon, in line with the chemical properties. What Mendeleev did is the same thing we do today in our periodic table. Elements with similar chemical properties are grouped together. The fact that chemical formulas change in a predictable fashion allows us to make some predictions of chemical formulas of compounds. Here are the top few rows of the periodic table. Knowing that sodium and magnesium react with chlorine to make NaCl and MgCl2, what would be the formulas for the compounds when calcium or aluminum react with chlorine? How about the series of these 6 elements when they react with oxygen? There is a pattern that forms with their chemical formulas. If you know the compounds that sodium, aluminum, silicon, and sulfur make with oxygen, what would be the formulas for the magnesium oxide and phosphorus oxide compounds? You might want to stop the video and think about these 2 questions to see if you can figure them out. Solutions will be in the reading.